Everyone can create a cluster. But can you keep it alive during an upgrade, a node failure, and a spot eviction all on the same day? Day 2 is where AKS careers are made or broken. In this video, we are going through 5 real AKS troubleshooting scenarios that interviewers love to use to separate operators from button clickers. Welcome back to the channel. If you're preparing for a senior AKS or DevOps role, you already know the easy part is creating resources. The hard part is what happens next. When upgrades hang, nodes go not ready, images stop pulling, and pods keep crashing. Today, we'll walk through 5 Day-2 scenarios. For each one, I show you the junior trap, and then the senior level answer that interviewers are actually listening for. Scenario number 1. AKS upgrade stuck because of a pod disruption budget. The interviewer says, "We triggered an AKS upgrade. The first node drained successfully, but the upgrade has been stuck on the second node for over an hour. What do you check?" A junior engineer will say, "I'll just run the upgrade command," or "maybe the control plane is slow." They treat this as an Azure problem, instead of a scheduling and disruption problem. A senior engineer immediately thinks about pod disruption budgets. AKS drains nodes during an upgrade. If a pod disruption budget has min available set too high, or max unavailable set too low, the node cannot be drained without violating that budget. So, I would run kube control get PDB -a. And I look for budgets where allowed disruptions equal 0, especially for pods still running on the node that AKS is trying to drain. If I find a PDB that's too strict, I have two options. Option 1. Temporarily relax or remove that pod disruption budget during the upgrade. Option 2. Carefully scale the replicas so the budget can be satisfied while nodes are draining. Describing this tells the interviewer you understand upgrades are not just an Azure platform operation. They are also a Kubernetes scheduling and policy operation. Scenario number 2. The infamous node not ready. The interviewer says, "One of your AKS nodes suddenly shows status not ready. Pods on that node are going pending, or crash loop back off. How do you troubleshoot it?" A junior engineer will say, "I'll just cordon and delete the node." That might recover workloads temporarily, but it tells the interviewer you don't understand what actually went wrong. Senior engineer will say, "First, I run kube control describe node name. I look at the conditions section. Is the ready condition set to false because of network unavailable, disk pressure, memory pressure, or kubelet not ready? If it's a kubelet issue, I know I need to look at the node itself. In AKS, I can use kube control debug node/node name. IT2 open a host level troubleshooting pod. From there, I check journal CTL, unit kubelet for kubelet errors, df-h to check if the disk is full, and system CTL status container or whatever runtime the node is using. If network unavailable is true, I check the CNI plugin and the underlying Azure NIC and the route table for that node. Explaining this chain shows the interviewer you don't just delete broken nodes. You know how to read node conditions and go straight to kubelet and OS level logs. Scenario number 3. Spot node eviction. The interviewer says, "You're running a spot node pool for cost savings. Suddenly, a bunch of pods disappear when Azure reclaims capacity. How do you design this so the application survives?" A junior engineer will say, "Spot is unreliable, so I wouldn't use it for production." That's not what the interviewer wants. They want to know if you can design around that unreliability. Senior engineer will say, "First, I assume evictions will happen. So I design my cluster with two pools, a regular node pool for baseline workloads and a spot node pool for burst capacity. I add tains to the spot pool, like spot equals true, no schedule. Then I add tolerations only to workloads that are safe to lose, such as stateless services or batch jobs. Next, I enable the cluster autoscaler with the right expander settings, so when spot capacity disappears, the autoscaler can scale up the regular node pool instead. For graceful shutdowns, I use spot eviction notifications and a node termination handler that watches the Azure schedule events endpoint and drains the node before it gets evicted. That answer shows you don't just say no to spot. You use it safely with tains, tolerations, autoscaling, and graceful eviction handling. Scenario number 4. Image pullback off from Azure Container Registry. The interviewer says, a new deployment on AKS is failing with image pullback off. The image exists in a CR, and you can see it in the portal. How do you troubleshoot this? A junior engineer will say, maybe the image tag is wrong, or I tried Docker login with the ACR credentials. They think like they're running Docker locally, not like they're running a managed cluster. Senior engineer will say, first, I remember that on AKS, the kubelet identity, usually a managed identity on the node pool, needs a CR pool permissions on the registry. So step 1. Identify the node pool's managed identity or service principal and verify that this identity has the ACR pool role assignment on the ACR scope. Next, I check the event details using kube control describe pod name and look at the exact message from the image pool. If it says unauthorized or denied, requested access to the resource is denied, that almost always confirms a permission issue. If the role assignment looks correct, I check whether the node itself can reach the ACR endpoint and whether private endpoints or firewalls might be blocking the pull. This answer shows you understand that on AKS, image pulls are done by kubelet identities, not by your local workstation. Scenario number 5. killed versus crash loop back off. The interviewer asks, how do you distinguish between a pod that is restarting because of an out-of-memory kill versus one that is restarting because of an application crash? A junior engineer will say, both are crashes. I'll check the logs. That completely misses what Kubernetes is actually telling you. Senior engineer will say, I start with kube control get pods and I look closely at the status and restarts columns. Then I run kube control describe pod name and scroll to the container state. If I see reason, killed and exit code 137, that tells me the container hit its memory limit and the kernel killed it. The fix is usually to increase the memory limit or address a memory leak in the application. But if I see reason, error and an exit code like 1 or 2 with no killed message, that means the application process crashed by itself. The fix is inside the application logic. Crash loop back off is not a root cause. It simply means Kubernetes tried to restart the container multiple times and is backing off before trying again. Being able to say, this is an application bug versus this is a resource limit issue is exactly the kind of clarity senior interviewers listen for. Those were 5 AKS scenarios that go way beyond just knowing the kube control commands. If you can talk through upgrades blocking on PDBs, nodes going not ready, spot evictions, ACR pull issues, and pod restart reasons, you're already operating at a true senior level. If this helped, hit like and subscribe for more real production scenarios. And tell me in the comments, which Day-2 incident hurt you the most and what did you learn from it? Thanks for watching.